Okay, Mr. Baumer here, and today we are continuing to work in Unit 6 on solving systems of equations. And today we want to apply what we've learned about solving systems, and we've learned to solve them three different ways: graphing, substitution, and elimination. And now we want to apply those techniques for solving the system to story problems that involve systems. Now, these get a lot easier if you'll try and focus on the strategies we learned today, because solving the system really isn't the problem to you guys. You guys have shown me you have some abilities there. The real challenge to a lot of you is, how do I write the equations? Given a bunch of information written in a story problem, how do I pull out what I need to write, in our case, two equations? So keep your focus there. So, again, hopefully you've written down the objective. If you haven't, you can go ahead and push pause, but we're going on to the first page. And let's read this first problem. It says, a professional organizer charges a $45 consultation fee plus $20 per hour. And her competitor charges a $30 consultation fee plus $26 per hour. Now, this is a system story problem. So we're going to have to, in our case, write two different equations. So the first thing is, well, let's talk about what are we writing? Well, we need to write an equation for our professional organizer, and we need to write a second equation for her competitor. And again, to be a system of equations, they have to use the same variables. So that's why down here, steps, or really strategies for setting up equations for linear story problems. A lot of you overlook this first point. What are the two things being measured? And that's really related to defining our variables. Well, what are the two things being measured? A lot of people read this and say consultation fee and amount per hour. No, those aren't variables. Her consultation fee is $45. It's not a variable. It's not changing. And her amount per hour is $20. It's not changing. What is changing, however, is how many hours she works and what the total charge is. So if we're going to write down what the two things being measured are, it's this: total cost, which we can represent with T, and hours worked, which we can represent with H if we want. All right, so now we have considered what two things are being measured and what variables we're using to represent those. Now we need to write two equations. Again, one of them needs to be for the professional organizer, and the second equation needs to be for her competitor. Now, the second thing we need to decide here is really, are we using standard form or are we using slope-intercept form? And to me, the key thing to look at is this. I really look for a B. Is there a y-intercept? Is there a starting point? Is there, when she hasn't worked any amount of time, am I paying her some money? And there is in this case. It's right here. It's her consultation fee. Before she's worked any hours at all, I owe her $45 just for coming over and looking at the project. That's a y-intercept. That's when x is 0, meaning when hours worked is 0, total cost is a value. It's $45. So that's an indication to me that I should be using this form for this problem, y equals mx plus b. Now, if we pull out that information, what I see is that I'm going to write one equation like this. Total cost, T, is going to equal some amount per hour plus some amount. Now, the consultation fee is the y-intercept, and the amount she charges per hour is really the slope. So our first equation is T equals 20h plus 45. And now our second equation, well, she's got a $30 consultation fee and $26 per hour. So again, total cost is going to be some amount times the hours plus some amount. $30 consultation fee and $26 an hour. So now I have written my system of equations. Now I've written my system. And if I go to solve this system, let's set it up down here. T is equal to 20h plus 45. And secondly, T is equal to 26h plus 30. Now, this is a system of equations, and I can decide, do I want to use graphing? Do I want to use substitution? Do I want to use elimination? To me, it sets itself up in this particular problem to use substitution, because I already know t is the same thing as 20h plus 45, or t is the same thing as this. But the key point is I've already gotten a variable alone. So what I want to do is I want to take this and put it in there. So the equation, and I'll make it a little bigger here now, becomes 20h plus 45 equals 26h plus 30. And now I need to solve that for h. Well, I'm going to move these 20h's over here by subtracting them from both sides. So at this point of the year, I'm skipping some steps because you need to be able to see when I move this to the other side, I subtract. So while I'm talking, I messed that up. But that leaves me 6h over here, and I still have 30. Now I need to move the 30 over here, so I subtract. So I get 15 equals 6h. Now I need to divide both sides by 6. So what I end up getting is that h is 2.5. Now, I haven't solved the system completely yet. When h is 2.5, I need to find out what t is. Well, I can take that piece of information and put it right in here. So 20 times 2.5. Well, 20 times 2 is 40, and 20 times a half is another 10. So that gives us 50. 50 plus 45 is 95. So now we need to make sure that I understand what this solution to the system, the math of the system, really means. Well, for what number of hours will the total charge be the same? 2.5 hours. If the project's only going to take 2.5 hours, doesn't matter who I charge, who I hire, first person or the second person. What will that charge be? $95 will be the total charge. Now, clearly, if I'm not sure how long the project is going to take, I may want to look very closely at who I hire. But let's move on to the next one. And again, practice some more of this. Now, Carl bought 19 apples. Carl bought 19 apples of 2 different varieties to make a pie. The total cost of the apples was $5.10. Granny Smith apples cost 25 cents each, and Gala apples cost 30 cents each. Again, write a system of equations to represent the situation. Now, in the last case, we used y equals mx plus b for both equations. Now, in this case, it may be different, it may be the same, but I need to consider, again, what are the 2 things being measured? What are the 2 things being measured? And really, it's right here. He bought 2 different varieties of apples. So I'm going to say, and define my variables as being this. Let's say that x represents the number of Granny Smith apples, and y represents the number of Gala apples. So now I have decided what 2 things are being measured, and I have defined my variables. Now that gives me a little ability to look at the information and try and pick out 2 equations, 2 relationships between these numbers. And now, again, I don't see, like I pointed out last time, I don't really see a b value. I don't really see a starting point in this. So that may be an indication that I need to use ax plus by equals c. Now, I know that the cost of the apples was $5.10. Now, Granny Smith's cost 25 cents each. So that's 25 cents times the number of Granny Smith apples I bought, plus 30 cents times the number of Gala apples I bought, and I spent a total of $5.10. There's my first equation. The second equation is the one that's tough for a lot of kids. They don't really see it, but it's right here in this first sentence. Carl bought 19 apples. So what we know is that x plus y equals 19. And again, it turns out both of these equations are in slope-intercept form. Now, I'm sorry, in standard form. So maybe if I set this system up down here, 0.25x plus 0.30y equals $5.10, and x plus y equals 19. How do I want to solve this? Well, since the last time I used substitution, I'm going to try elimination here. What I could do is multiply this entire equation by negative 0.25. By negative 0.25. Now, when I do that, The first equation stays the exact same way it was. And the second equation becomes negative 0.25x minus 0.25y. And now what is negative 0.25 times 19? Well, a positive times a negative is going to be a negative. And 0.25 times 19 is 4.75. Now I've set myself up to use elimination. So I can add these two equations together and eliminate a variable. When I do that, what I end up doing is eliminating the x's. Now, 0.30y plus negative 0.25y leaves me 0.05y equals. Now, what is $5.10 plus a negative $4.75? Well, that's 35 cents. Divide both sides by 5. I find out that y equals 7. Now, if I bought 7 of the Gala apples, that must mean, from this information and from this equation, that I bought 12 of the Granny Smith apples. So, how many Granny Smith apples did I buy? 12. How many Gala apples did I buy? 7. I'm interpreting my two answers, or my one answer really, but I'm interpreting the parts of it in terms of this story problem. So again, that was the second example where we really followed this strategy. Let's look at the third one. Bob is 6 years older than his sister Sue. So to me, the two things being measured are Bob and Sue. Let's use B and S. What do we know about Bob compared to Sue? Well, we know that Sue's age plus 6 equals Bob, because Bob is 6 years older than Sue. And what do we know about the sum of their ages? Well, we know that S plus B has to be 70. So again, both of these are actually written in standard form. S plus B equals, first one's written in slope-intercept form. All right, and the second one is written in standard form. So this one, we're mixing it up a little bit. Now, how could we solve that? Well, it might be easy for us to go and get S alone in this equation. We could transform this equation, if we want, into, so we could say, so that means S is the same thing as B minus 6. And in that case, we've got an S alone, and we can take that and put it in the second equation. So I want you to try and solve this system and tell me how old Bob and Sue is. And when you come into class, the next class, you'll have a little understanding of how we transform written story problems into systems of equations, and we'll be able to spend the entire class working on doing that. So again, try and finish this problem on your own and come into class prepared. Thank you.